Okay, hello everyone. Welcome back to my channel. Char lang. So, um, our lesson for tonight is um, in continuation for in continuation from the previous topic. We had confidence interval and margin of error. So, in this past two lessons, we learned how um, to get the length of confidence interval, and we also learned how to solve for the sample size using the margin of error, right? So in this video I'm going to discuss how we draw conclusions about population mean based on the statistic value and critical region. So I've discussed this on face-to-face during our face-to-face classes, where um, uh, I differentiated between the Z and T tables. So before you continue this, get your calculators and your table 1, 2, and 3 with you. So get your T and Z tables. Okay, so here in example 1, it says compute for its value given the following information. Use alpha equals 0.05. To recall, alpha is what? The level of confidence, right? Or confidence level. So interpret the results. So these are already the given here. So the null hypothesis is that mu is equal to 70, and its alternative claims that mu is greater than 70. So we have this greater than symbol. This implies that it is a one-tailed test. If if it's not if it's not equal, if the alternative is not equal, that is called a two-tailed test. But here in the given, it uses greater than symbol. It's a one-tailed test, same as the less than symbol is also a one-tailed test. Here in here in the alternative hypothesis. So these are the given. We have the population mean, which is 71.5, and the standard deviation for the population equals to 8, and n is what? Greater than 30. This is n equal to 100. So what should we use again if n is greater than or equal to 30? Correct. We should use the z table. So to solve for z, we have z equals x bar minus mu over sigma. Okay, I'll transfer it. Wait. Oh. Ito. Oh no. Nawala. Unbelievable. Grabe. Putol ko yung tao ko. Ganyan na lang guys. I'll write it here again. Okay? So, you can just go back to the video. I'll write the given here. So, h sub o is mu is equal to 70. H sub of, no. H sub a is alternative hypothesis is mu is greater than 70. X bar is 71.5, and the sigma is 8, the standard deviation, and n equals to 100. So this is called a one-tailed z test. Why is it one-tailed? Because directional, the signs here is directional. If it uses a not equal symbol, that is a two-tailed z-test. It's a z-test because n is greater than 30. Okay, so to recall, to get the z, we have x bar minus mu over sigma over square root of n. Okay, so we have this given 71.5 minus mu 70 and 8 over square root of 100. So get your calculators. You should have, let's say, 1.5 over 8 over 10, 1.5, 0.8. In your calculator, it should be uh, 1.5 divided by 0.8. That is 1 point, oh sorry, 1 1.875. Okay. Now let's solve for the critical values of z. So this is a sub lesson. This is actually an side note. Find oh sorry. Find the critical values of z when it is a right-tailed test. Okay, what do you mean by right-tailed? Do you remember that our null was mu equals 70 and our h alternative is mu greater than 70, right? So this is right-tailed because our our inequality sign here is facing to the right. Okay, so how do you find the critical values of z when it's in a right-tailed test? So uh first, um we should note that from the given our alpha was 0.05. Am I correct? Yes. If you can go back to the previous minutes ago, our alpha was 95. Our alpha was 0.05. And so to find the critical values, we should know that um, if you look at here, when um, if you're familiar or if you can recall, that confidence level is actually 1 minus alpha times 100, right? And therefore 1 minus 0.05 is times 100% CL. And then we have CL is what? 95%. This is 0.95 times 100, right? So our CL is 95% or 0.95 again. 0, 0. So if you look at our standard table here, let's look at the area which we are 95% uh which we have a 95% level of confidence. Okay, I'm using the standard normal table. So we have, let's say, 0.9 I'm looking for exactly 0.95 here. So I think I found it. So this is actually 1.64. Um, to get exactly which critical value. Let's say we have, I'm gonna pause this one. Sheesh. Wala na ko space. Okay. Our critical values should be our z our z critical value should be equal to 1.645. Ma'am, why man nga kon nga no man na ay 5? You look at this. This is 0.94950, and this is 0.95053. And to get you should just get the average. I think you solve for this one. You have 0.04 uh, 0.04 plus 0.05, this one and this one. You get the average divided by 2, that is 0.045. Therefore we have 1, this is 1.6, we have 1.6 plus 0.045. Therefore we have 1.645. So this is the critical value, z crit value for right-tailed test at alpha 0.05. Okay? Therefore, this is, let's say this is 0, and this is what? Negative 1.645, and this is positive 1.645. You reject your values, you reject the null hypothesis if your z value falls beyond this region here. So if we check, our z was 1.875, correct? That is 1.875. Therefore, this is somewhere here. Z equals 1.875. Note that any value, if our z falls here in between negative 1.645 and 1.645, our we fail to reject the null HO. If it falls beyond these critical values, then we reject HO. So how do we actually formulate this one? We can say that therefore the null hypothesis is rejected. Rejected since what? Since the z value 1.875 is greater than the z crit 1.645. Again, therefore, the null hypothesis is rejected since the z value, which is 1.875, is greater than the z critical value, which is 1.645. There is sufficient evidence to conclude that mu is actually greater than 70. So this is how you should formulate your conclusion. Something like this, something na digestible. Okay? So for another example, we have should go back, since this is example 1, should go back here, example number 2. Compute for its value given the following information. Use alpha 0.01, interpret the results. So these are the given. Okay, so we have what? N is less than 30. What should we use for this? The t table. This follows a t distribution. Okay, so should actually add here the degrees of freedom, which is n minus 1, and this is 12 minus 1, so v is equal to 11. So the t distribution looks like this: x bar minus mu over x bar minus mu over s over square root of n. So this is a one-tailed test, and it is a left-tailed, since this is the less than value. Left-tailed. So x bar is 124.5 minus mu, which is 127 over s, our standard deviation for our sample, and n 12. This is negative 2.5 over 5 over 3.46. Therefore, we have negative 2.5 over 1.44. Therefore, our t is negative 1.736. Okay, so unlike in z table, guys, you can actually find it easier for the t table because we have the degrees of freedom 11. So if you have your t table with you, we can easily look for the t critical values. So it's a one tail test, and it's 0.05, 0.01 here, and the v here, the v or degrees of freedom, that's 11, so it's actually 2.718. 2.1, the t crit is 2.718. 0.01 ang one-tailed alpha, and the degrees of freedom is 11. So let's go back. We have our t crit is plus minus 2.718. Therefore, if you look at our normal curve, this is 0, and this is 2.718 positive, and this is negative 2.718, and our value here is negative 1.736, right? So it falls somewhere here. Again, we only reject the null hypothesis if it falls in the rejection region. This is the rejection region here. What are the ones I'm shading? This is the rejection region. So you reject your null if your value falls somewhere here or here. But since it doesn't fall in the rejection region, you have this conclusion. Therefore, the null hypothesis is not rejected. Therefore, there is no sufficient evidence to conclude that mean our sample mean is less than 127. Okay, so we have example 3 here. I'll leave this activity for you, and I to grow the engagement of this channel, guys. You can comment if it's reject the null or do not reject the null. You can comment either reject null or do not reject null. Okay, so please use a YouTube account using your name, okay, when you comment, so I can add points for that. So here you have the government claims. The government claims that 10,000 pesos is the monthly expenses of a Filipino family with 4 members. So do you believe that 10,000 for a Filipino family na naay 4 members? Sheesh. A sample of 26 families has a mean monthly expenses of 10,900 pesos and a standard deviation of 1,250 pesos. Is there enough evidence to reject the government's claim at 2.5%? So I'm going to help you out here, class. I'm going to find the critical value, or do I need to find the critical value? This is less than 30. I'll just give you the given. Okay, so there's a critical value, but it's for what? T or Z? You decide. So let's say here we have our null. Here is mu is equal to 10,100 10,000 pesos, and our alternative is h sub a is not equal to 10,000. Ma'am, how can we know sa problem if it's not equal? We are using a two-tailed test here because wala I mean the problem does not mention the direction of the distribution. Wala siya nag-ingon if there's no argument. I mean, wala tag-assume, nag-argue siya na the mean should be greater than 10,000, right? There's no argument here. Our argument is that it is not equal to 10,000. It's not specific if less than ba or greater than 10,000. So, since wala siya gi-state if our argument here or our alternative hypothesis is greater than or less than 10,000, we should automatically assume that it is not equal to 10,000. Okay, our sample mean here is 10,900. From our data, it's actually 10,900. And our what? Since this is 26, this is less than 30. It is a sample size, which is 1,000. Sample size, our n is 26. We should use the S standard deviation for samples. We have 1250. So those are the given. Okay, so the alpha here is 2.5%, which is in 2.5 this is 0. 0.025. So let me know in the comment section if you reject or do not reject the null hypothesis. Okay, so guys, I want you to know na I think you will find it confusing how to find the critical values for z. It's much easier for t, but for z, like just going to add it here. Ma'am, what if maghimal-himal lang ko given? What if our alpha is 0.01 and our null hypothesis, the what if example. What if? So our null is mu is equal to uh let's say again, let's say 70. Let's use this, mu is greater than 70, and our n is what? Or in our previous example, our n should be 100, and it should be greater than 30 since we want to what if z, diba? So our x bar, let's say again 71.5, and our standard deviation sigma is 8. Okay, so we know that z here is x bar minus mu over sigma over square root of n, and this is 71.5 over the minus 70 over 8 over square root of 100. The answer for this was 1.875. So z value is 1.875. But you don't know earlier, diba? This is 0.05. Alpha is 0.05. We don't know unsa ang z crit if 0.01. So z crit, unsa ang z crit at alpha 0.01. So we know that confidence level is 1 minus alpha times 100%. And then we have 1 minus 0.01 times 100%. Therefore, CL is what? 0.99. Or what? 99%. Or 0.99. So we look for the area. We look for 0.99 in our table. Here, standard normal table. 0.99 here is either here or kani. Sakto ba? 0.99. These ones are the closest. So we have 2.3. Let's write it there. Nalag. So we have sheesh. Our z crit. Ooh. See. Never mind. Our z crit is 2.3. We don't know the something here. It's 2.302 og it's in between 02 and 03. So 0.02 plus 0.03, ang average niya divided by 2. So 2.3 plus samukoy. plus 0.025. So we have 2.325. Therefore, moms and sirs, this is positive 2.325 and negative 2.325. And what? Asa ni nag-fall si 1.875? Somewhere here. Diba? So, now we know that, therefore, the null hypothesis is not rejected since z value is less than z crit. There is no sufficient oh no sufficient evidence to conclude that mu is greater than 70. So, actually, if you can recall, if kanilang bitaw, if this one is alpha equals 0.05, we can reject the null. But, if mangutana ta, if 99% sure baka ka na greater than, di ka kaingon. Makaingon ka if 95% sure. But if you're asking if 99% sure baka, no, you don't. That's you don't have enough evidence to say that at 99% level of confidence. Okay? You can say that at 95% level of confidence, but not at 99% level. So that's the implication here. So, class, I hope you learned something from this video, and I think when we get back, we will have a quiz. You should definitely watch this one. We will have a quiz on the topics we had so far, starting from the confidence interval. Yeah. Okay. So, if you have any questions, you can comment sa comment sections. Thank you, guys.